Chapter 8, Day 1. We are going to talk about greatest common factors today and just factoring in general. So here's kind of maybe something you can connect to what we're about to do. Let's say you're at the bank and you want to exchange a $100 bill. What money can you ask for in exchange? And how many different ways could you ask for money so that you get your whole $100? Well, one of the choices would be to get two $50 bills. Okay, that's one way you could do that, because you take 100 and you divide it by 2 and you get 50, two $50 bills. Or you could ask for 10 $10 bills, right? Because 10 divides evenly into 100 and you would get 10. Or you could have, you could ask for 100 ones. And then we could ask for other things, like we could ask for fives. And if we asked for $5 bills, we would get 20 $5 bills, okay? The point here is that we have a number, 100, and we can divide that number different ways. And that's what we're going to be doing when we factor, is we're going to be dividing into equal amounts. But notice when we were exchanging this money, we did not get decimal numbers. We couldn't divide 100 by 3, okay, because you would get like 33 $1/3. Well, you don't have a bill that equals that. So sometimes it's not all possible combinations. It's more just the natural integer combinations. Let's take a minute here to review. This one talks or works through some of the things we did in Chapter 7, the difference between adding two expressions and multiplying. So why don't you go ahead and try these and then check back to the notes to see if you got them correct. I'm going to explain two of them just to have some common knowledge and common ground to start with here. But I would like you to pause the video and try these. Okay, the difference between adding is we can only add and subtract like terms. So the 3x can be added with the 5x to get 8x. And then we have 4y and 8y together, and that would give us 12y. So we can only add and subtract like terms. Now, if we look at something like number 3, now we're multiplying these two expressions. And when we multiply, we need to make sure that we are multiplying this 9 right here to each of those terms, but we also have to multiply the x to each of those terms. And we used a process called FOIL. So when we multiply this first term right here and this first term together, that's the FOIL in FOIL. And that's the first term in each parenthesis, and that would be x times x, or would give us x squared. If we multiply the O, that is our outside terms. So this term is on the outside and this term is on the outside. So the O in our FOIL is going to be multiplying x times -5, which is going to give us -5x. Okay, the inside terms come from multiplying these two inside-most terms, and that would be 9 times x, and that is our I, and that would be 9x. And then we look at the last term in each parenthesis, and that would be this term right here and this term right here. So our last terms would be multiplying 9 times -5, or -45. And from there, we have to combine all of these together if we can. Well, the only things we can combine, again, are our like terms. And so what we can combine here are the -5x with the positive 9x. So our final answer for this question would be x squared plus 4x minus 45. So that's just a review, because what we are going to do today is we are going to start with the trinomial, okay, that you see right here, and we are going to break it up into their two factors. Now that's the process of factoring. We're actually not going to get into that particular type today, but we are going to be doing some of that work. So here's another example that you can kind of think through about dividing up brownies. Try to brainstorm different ways that you could do that. okay, if you have 4 people. And so these were our learning targets. We're going to find factors of any monomial. So factors of 100 that we did with that dollar bill would be 10 and 5 and 20, etc. Those are all numbers that divide in evenly. And then we're going to find the GCF. Hopefully you remember GCF is greatest common factor. And then we're going to factor using the GCF. So again, the more you understand this multiplication process of the distributive property, the easier this lesson will be to factor using the GCF. So again, if we are doing this question right here, we are going to multiply that x to each of those terms. So we have x times 5x, which would give us 5x squared. We have x times 2, which is going to give us 2x. We add these together, although we cannot add them together because they are not like terms. One is an x to the first and one is an x to the second. You can only combine the exact same variables to the exact same power. Okay, so why don't you try multiplying number 3? Pause the video and then restart the video to see if you got it correct. So what you should get is 24x plus 30. And again, if you didn't understand that, I will work it out with the steps for you to see. But I wanted to show you this because what we are going to be doing today is we are going to start with this and we are going to find the greatest common factor between these two terms. And we are going to factor that out and then divide each term by that greatest common factor. So what we would be looking for is we are looking for a common number that goes into both 24 and 30. Well, 2 goes into each, okay, because 2 times 12 is 24 and 2 times 15. But we're looking for the greatest one that's in common. Well, what about 6? 6 goes into 24 and 6 times 5 is 30. So our greatest common factor here is 6. And so we can factor that out and put it on the outside of the parenthesis. And then what's left is when we divide this by 6 and this by 6, which gives us 4x plus 5. And now notice that's what we started with when we multiplied. So that's kind of a preview of sort of, again, what we're doing with this great factoring using greatest common factor. So I'll work out the other two, questions 2 and 4, just for the multiplying piece for you to see and practice. Because again, the more you understand multiplication and how it works, the easier it's going to be to divide. So here's some vocabulary. So a factor of each numbers is when two numbers are multiplied, they form a product. And each of those numbers is called a factor of that product. And a number is always divisible by its factors, which means it has to divide evenly, not with a remainder or a decimal. So when we look at factors of 15 and 35, well, 3 and 5 are factors of 15, 1 and 15. How I like to usually do this is write 1 times 15. That's always going to be factors, 1 and 30. And I purposely put that way far out there because then I check to see, does 2 go into 15? No, it doesn't. Does 3 go into 15? Yes, 3 goes in there 5 times. And again, I put it over to the side. Now I check 4. Does 4 go in there? No. So now I know my list is complete. And you can see the two lists are the same. I can do the same thing for 30 or 35. 2 does not go in there. 3 does not go into 35. Oops, this should be a 35 here. 4, no, 4 doesn't go in there. You check it on your calculator. If you get a decimal, no, it's not divisible. But 5 goes in there 7 times. Now I check 8. No, I check 6, sorry. There's only one other number in between 5 and 7 right here, and that would be 6, but it does not go in there evenly. So 35 is not divisible by 6. So now I have my whole list, and then I determine the greatest number in common. And what is the greatest number in common from both lists? And that would be 5. So what is the greatest common factor? The GCF is 5 between those two numbers. So that's just some things that reviewing from what you've learned in the past. Okay, here is a way to do the same process but with using a multiplication chart. And some students really like this method. It's not one that I have taught much of in the past, but I'm including it here because it does work well for some students. So what we do for the greatest common factor here, and by the way, your GCF, you need to know, stands for greatest common factor. So make sure you write that in there, that this is the greatest common factor. And it is the greatest integer and the greatest power of each variable that divides evenly into each term. So right now we're only working with numbers, but we're going to eventually have variables as well. So as we continue on here, let's look at this chart. So you can see what I did first was I circled all of the numbers 15 and 35 anywhere in this chart. And then what I did is I looked for the numbers 15 right here and 35 to be in the same column. And then I looked and saw that the greatest number in common is this number right here on the top. So 5. So it's just another way of looking at it. And here's some steps for doing that as well. So let's try this one. It says find the GCF of 24 and 36. So again, circle all the numbers, circle the two numbers that you're looking for the greatest common factor of in your grid or in your chart. So this is circle all the numbers in the chart. Okay, so I've circled 24 and 36. Now there may be a few more in here that aren't circled, and you might not circle all of them because what you're looking for is you're looking to find both numbers in the same column, like lined up. Okay, so these two numbers right here are in the same column, and so are these. Okay, so these are columns. Columns go down like this. And the GCF is going to be the highest number that both share. So if you look at this column, 12 is now a bigger number than 6. So the greatest common factor then is this 12. So you're always looking for them to be lined up in a column and furthest to the right. Now again, some people find this confusing, so you don't have to do it this way. I will show you another way as well. But let's practice one more of these because sometimes you don't know if this is the preferred method if you've never tried it. So again, the first thing I was supposed to do is circle any 30s and 80s that I see. So here's a 30. And here's an 80, and I'm kind of starting to the right side because those are going to be my biggest common factors, and I'm looking for them both to line up. And I already have that here, but I thought I would try to find 30 and 80 in other places just so you can see that there are other places where these are. And I don't know if I found all of them right now, but what we're looking for again is to find them in the same column like this. And I'm looking for, if they appear in more than one column, I'm looking for the one that's furthest to the right. And I don't think I have them lined up anywhere else, so my greatest common factor is this number 10. So the GCF is 10. That is the largest number that divides evenly into 30 and 80. Now, here's maybe a more traditional way of doing this that maybe seems a little more intuitive for some of you, but maybe not. So it says, another way to find the GCF is to find the largest common factor between both numbers. And to do that, we write out all of the factors for each number, and we circle the greatest factor that both numbers share. So again, 1 times 30 is 30. 2 times 15. 3 times 10, and then we have 5 and 6. Okay? So I do that for both of those numbers. And then I can see that 10 is the largest number in common. There is another number in common too, okay? But that's not the greatest number in common. And that's how we do GCF. So this GCF is equal to 10. All right, so sometimes what happens, and I'll show you on this chart, is that when you circle all of your numbers, they don't line up. So if I circle any places where I have 11 and I have 18, and let's see, here's an 18, and here's an 18. And I think that's all I have. But notice how none of them line up with both numbers in the same column. And so when that happens, we call this relatively prime. So relatively prime, again, this is something that you want to know and keep track of. Relatively prime is when the greatest common factor is 1 and there are no common letters. So we call that relatively prime, and we can write RP for relatively prime. It doesn't happen that often, but it does occur. So let's move on to talking about how do we do this if we have letters and not just numbers that we've done so far. Well, we kind of have already addressed how to do it with the numbers, but then what happens with these letters? Well, to find the greatest common factor of variables, okay, what we do is we take the smallest exponent of a variable that is in each term. So if you look at number 1, you have 3x and 9. So the factors of 3x would be 1 and 3 as far as the number part. And then you also have this sort of x hanging out. The factors of 9 are 1 and 9, but then 3 goes in there 3 times. But I don't write the 3 a second time. Those are all the factors, 1, 3, and 9, that divide into 9 evenly, and there are no variables. There are no x's in the bottom. So the greatest common factor of these is just the number 3. So our GCF is 3, okay? But let's look at this bottom one. Okay, so now we're looking for the greatest common factor of 2x and 8x squared. Well, for 2x, we'd have the number part, 1 times 2, and those are the only factors. But then we have an x and an x. That makes x squared, x times x. So now we look at 8. We have 1 and 8. 2 goes in there 4 times. And now if I check the number 3, that does not go in there evenly. So those are my factors. But I also have 2 x's down over here. And actually in my first one, going back, I only have 1 x. So now, what is our greatest number in common? Let's do that first. We should be getting better at that. So our greatest common factor for the number piece is 2. But notice we also have 1 x that's in common to both. So our greatest common factor is 2x. So this is how this bottom piece works, where it says take the smallest exponent of a variable that is in each term. So if you look at this term, you have x to the second here. Here you have x to the what power? Well, that has a power of 1. So I'm taking the smallest of those two, which is x to the first. So I look at my exponent, again, and I'm looking for the smallest exponent of the variable that is in each term. And above, this would really be x to the first, and 9 would be x to the 0. So I have 0 x's to include. So that's kind of how it works with numbers and variables both. So now let's have you try one. Well, actually, let's try one together, and then I'll have you try one and check the notes. All right, let's do one more of these together. So it says, find the GCF of the following. We have 4x to the third and 16x squared. So I like to do mine this way. You can use the chart to find the number piece, but not the variable. So the factors of 4 are 1 times 4. 2 goes in there 2 times, but we're done because 3 doesn't go in there evenly. So how many x's do I have in that first term? I have 3. And I kind of like listing them out, but you don't have to. You can look for the fact that there's a common x, and the smallest exponent power is 2. But we'll go ahead and keep going. So we have 1 and 16. 2 goes in there 8 times. 3 does not go into 16, but 4 goes in there 4 times. So we're done with that list, but now we have 2 x's. So first pick out the greatest number in common. So again, we see we have a 2, but 4 is the larger number in common. So my GCF is 4, but there's common letters. There's an x common here and an x common there. There's another one. So it's 4x to the second power. So again, it's the smallest of the exponents, not the largest. I know that's kind of counterintuitive, okay? But that's how this works. So I'm going to let you try the next one on your own, and then check the notes for more information and to see if you got it correct. So the last thing we need to talk about here is factoring. So to factor, okay, using the GCF, what we're going to do is we're going to find the GCF of each polynomial. So the first one is done for you, okay? You have your factors of 20y. They didn't put all these on here, but you also have 1 and 20. The factors of 5 are just 1 and 5. So 5 right here is our greatest number in common. Since I don't have a y down below and I have one above, I can't circle it. So my greatest common factor is 5. Okay, let's get the greatest common factor of the second one. Okay, so my factors of 2x are 1 and 2 and 1x. My factors of 4 are 1 and 4 and then 2 times 2. So the greatest common factor here is 2. Again, notice there is not an x in each term, so you cannot have a x in common to factor out. So my greatest common factor for number 2 is 2. Okay, let's do the third one together as well. So again, the factors of x squared are x times x. The factors of negative 8x, or we'll just go with 8x because we can keep the sign in between when we factor, would be 1 and 8, and there's a 1 in front of here too, but 1 and 8, and then we have 2 and 4, and then an x. So notice we have no common numbers except if we want to include the number 1, okay? 1 times 1 is 1. But what we do have is a common letter x. So in this case, our GCF is x, okay? Now, that's step 1 of factoring, okay? What we're doing is we're going to take each of these expressions and divide it by the greatest common factor. So here's our second step. Step 2 is we're going to do what's called factor that GCF out, which means we divide it from each term. And so the format that we're left with for our factoring process is our GCF is on the outside the parenthesis, and what is inside the parenthesis is what's left after we divide by that GCF. So factoring the GCF is really reverses or undoes the distributive property. So we already found the greatest common factor of those two numbers, and that was 5. So we put the greatest common factor out, and then what goes inside is what happens when we divide each of those by 5. Well, 20 divided by 5 is 4. So we'd have 4y. 5 divided by 5 is 1. We still need that placeholder in there, and that is our answer. That is factored. That's our answer. Okay, let's do the second one. All right, so we already figured out on the last slide that the GCF of these two is 2. So the GCF goes on the outside, and what goes inside the parenthesis is what's left after you divide each term by 2, by the GCF. So 2 divided by 2 is 1, so we get 1x, or x, plus, and then 4 divided by 2 is 2. And again, that is factoring using the greatest common factor. Now, let's just stop for a minute here. If I were to multiply using the distributive property here, look at what I would get. I would get 2x plus 4. Notice these are the same. And that's how I know that I factored it correctly, because factoring is the reverse of multiplying using the distributive property. All right, here's our last one we'll do together for right now. So again, we already found out our GCF is x. So when I divide both of these terms by x squared divided by x, remember we subtract those exponents and we get x to the first. And then we have, just keep that sign that's in the middle consistent. And then 8x divided by x just gives us 8. So again, that is our factored form of our binomial for number 3. And I know this can be tough, but keep practicing, keep trying, okay? I am going to do, we'll kind of do these. Why don't you try number 4 on your own, stop the video, try number 4, and then restart it, and I will explain the process again. Okay, so now we have to do both steps. First, we have to find the GCF of these two. And the GCF of 5x squared is 1 and 5, because it's prime, and then x times x. And the GCF for 20x is 1 times 20, 4 times 5, and 1x. So now look for the largest number in common, which is 5, and the greatest number of x's you can circle is 1. So our GCF is 5, but we're not done. So now we take that GCF and put it on the outside of the parenthesis. What goes inside, 5x, sorry. So what goes inside is what happens after we divide this by 5x, each piece by 5x. So 5x squared divided by 5x is just a single x. Negative 20x divided by 5x gives us minus 4. And remember, you can always double check these by multiplying them back together. And if you multiply and get what you started with, then you know you've done it correctly. So this last one, number 5, is just a little bit more complicated because it's a trinomial, 3 terms instead of 2. But we do the same kind of thing. So to find the GCF, we are looking for the GCF of 7x, of 21x squared, and of 49x to the third. So 7 is a prime number. So it'd be 1 and 7 and an x. 21 is not prime. So we would have 1 and 21. We'd have 3 times 7. And again, we can check all the numbers in between 3 and 7, but 4 and 5 and 6 do not go in there. It's not divisible by those because they would not go in there evenly. So now let's look at 49. We have 1 and 49, and then we have 7 times 7. And we don't need to include that second 7 right there. So now we'll look at, I'll move this 49 over a little bit. And now we have 3 x's here. Oh, I forgot the x's on this one. There were 2 x's here, 3 x's here. So first find the largest number in common. There's a 7. That is the greatest common factor. So our GCF is 7. But then we also have 1x here. We have 2 here, but only 1 in common. And we have 3 in the bottom one, but only 1 in common. So our GCF of this trinomial is 7x. So remember, the 7x goes on the outside of the parenthesis, or the GCF. What goes inside is when you divide. Now 7x divided by 7x doesn't just cancel out and go away. It stays a 1. Anything divided by itself is 1. 21x squared divided by 7x. 21 divided by 7 gives us a 3. X squared divided by x gives us x. And notice I just put a plus sign in there. If there's no negative, you just continue with the same signs. And so now I divide by 7x again, and that would give me 7x squared. So that is factoring, the process of taking a polynomial and breaking it down to its greatest common factor, and then what remains after dividing by that greatest common factor. Now there is one more slide here. If you want to try these on your own, then you can check the notes to find out if you've done them correctly.